Notes today are going to be fairly short. Mainly, it's a lot of, like, you've just uncovered the law of signs on your own by doing that activity on the pink sheet. We're going to write down the law of signs in our notebook so that we have it down, we know what it looks like, we know what it is. And then we'll look at an example. I'm going to let you try the example before I do it. Okay, so you know what the law of signs says. Can you plug into it? Can you make it useful to you? Okay. And then before we finish up the notes for today, we're also going to look at the area of triangles that are not right triangles. Okay, so this is chapter 6, section 1. We're going to talk about law of signs. I want you to think about how, like, you are doing the brunt of the work today. You just uncovered the law of signs. Okay, you've got that. Tomorrow when we look at the ambiguous case, I'll spend a little bit more time introducing that, but you have a handle on this right here. So first thing we want to do is copy down the law of signs. Law of signs would start with a triangle, ABC. It doesn't matter what your triangle looks like. It doesn't matter which vertices you label A, B, and C. That is totally up to you. So it does not have to look exactly like the image that I have on the screen. I think the key piece to drawing your triangle is just what has always been true since geometry. After you label your vertices, the side opposite angle A is side A, the side opposite angle C is side C, and the side opposite angle B is side B. Okay, so it's important that we label all triangles like that. But their orientation or shape doesn't really matter. Okay, so you've got that picture, and then write down the law of signs. I'm actually going to take equations 6, 12, and 13 and put them all together. Okay. So I'm going to say the law of signs says the sine of angle A divided by side length A is equal to the ratio of sine of angle B divided by sine length B, which is also equal to the sine of angle C divided by sine C. You found that out in the pink activity. And if you didn't finish the full back page, you could go back and you could draw on that altitude and run through the same process and see that that's going to become true. Okay. So the ratio of the sines of the angles to their opposite sides is the same in all triangles, right triangles or not. Okay, so you can use this for what we would call oblique triangles, triangles that are not right. Okay. Now, on the pink sheet, you wrote them out so they were more like a standard equation with one equal sign. Okay? And so you are going to, when you work out a problem, you're going to pick from the 3 equations that I have on the board. Do I just want to use A's and C's? Do I want to use B's and C's? Do I want to use A's and B's? Okay, it just depends on what information is provided to you in a triangle. Okay, so here is a triangle. And again, it doesn't really matter what your triangle looks like. I don't ever care what your triangle looks like, other than it has 3 sides. The key piece would be the labeling of your triangle, so that you have like the same angles labeled with the same measurements that I do, and then the correct side length is labeled. So I've got triangle ABC. Angle B is 118 degrees. Angle C is 36 degrees. And side C, or segment AB, is 14. Basically, we're going to use the law of signs to solve the triangle. And if you think back to chapter 4, we solved right triangles. When we solved right triangles, it meant tell me all the angles, tell me all the sides. And you'd use Pythagorean theorem and SOHCAHTOA, whatever you needed to solve. Okay? I want to know, what are all the angles, what are all the sides? You can't use Pythagorean theorem, because it's not a right triangle. And you can't use SOHCAHTOA, because it's not a right triangle. You don't have a hypotenuse. So your one tool that you have for me right now is law of signs. I'm going to give you some time. to kind of think about how you might get started, you might have a chat with the people around you, small groups, partners, talk about what you think you could do with that log signs that would help you solve for the missing angles, missing sides. Okay? Go ahead, see what you can get done. So let me ask you this. You're writing sign 14 over B. When you look at and you're putting it over B, which is 14, what is it asking for you to know on the side? What does that capital B represent? Angle B. Do you know angle B? It is. So instead of saying this ratio, you don't take signs of ratios, you take signs of angles. Instead of putting a ratio there, put the angle there. Sine of 118 degrees over 14. Then you have the angle and its side length in the denominator. But this 36 degrees is what side or angle? C. Oh, that's side C. Okay, yes, sorry. I thought you had it as B. You will not need to draw the altitude. You'll now just use the log signs. So just looking at the log signs, what can you do? Do you know any A's, B's, C's? Oh, okay.
I'm going to do something.
So I would definitely use the ratio.
And then it's just close to
And which other one you might like to use?
Oh, we know, it was the 2A.
same exact thing.
Except, you know, I just first.
Okay, what were they? Okay, so you need to think about the things that are labeled on the triangle. The things that are labeled on the triangle, so you know A's, B's, or C's. So then I definitely use this one. You could write sine. But what is the sine of angle? Okay, so you want to like plug in numbers for A, B, and C, right? If you keep writing letters, you're never going to spell, right? Over C.
That makes sense because it's the biggest angle.
And then think about what equals, what the ratio might be. Sine.
She's going to keep something else on the right there on the line.
So that means I will use that to do line, angle A, and then so just write this. Yes.
You got it.
Yeah, sure.
Let me read.
Oh, that would be so helpful.
Sine 36 over 14. Relation is you want this? Okay.
Or maybe not.
Go that way.
Yeah. And, Michaela, would you put your setup on board? Put these ladies on the spot this morning. Thank you.
Just the first part.
Yeah, just the setup. Okay, thank you. Okay, so I had Mary Kate and Michaela go up to the board and just put their beginning setups. Notice that when you're doing the law of sines, you're not going to write out like the equation that I put up on the last slide that has 3 things, because we don't solve equations that have 2 equal signs, generally. Okay, so we want to set up an equation using 2 of those ratios. And a big question that I asked people as I was walking around the room and people were getting started, if we were getting a little bit stuck, I said, well, look at your triangle, what do you know? And what's the most important pair that you know on the triangle? Which letter? The C's, right? Because you have angle C, 36 degrees. You also know side C is 14. So you know one value of one ratio. Whatever sine of 36 divided by 14 is, that's going to be some kind of decimal, and that's the ratio for all the other sine B over B, sine A over A. Okay, so notice that in Mary Kate's setup, we see that sine C over side C, sine 36 over 14. We also see the same thing in Michaela's, sine 36 over 14. So you want to use that one where you know the side and you know the angle. Okay. Mary Kate's setup is going to solve for side A, which I could go ahead and label on my triangle here. And Michaela's setup is going to solve for side B, which is here. Who had to do a little bit more work to create their setup? Left, right. Which one requires a little bit more work? The left side. Grace, what does the left side have to do?
You have to find the angle A.
Yeah, right now, angle A and side A, neither is marked for us. So we don't know angle A, we don't know side A. Without knowing one of those things, we would be unable to use the law of sines. So we either have to know the angle or we have to know the side length so that we can create that ratio and set it equal to the ratio we have full knowledge for, sine C over C. Okay. So Mary Kate did a little bit of work there. Tell us, Mary Kate, real quick, what did you guys do to get that angle 26 degrees?
You add 118 and 36 and subtract that value by 180.
Okay, 118 plus 36 and subtract that from 180. So you're using a very basic formula from geometry, triangle sum, triangle angle sum theorem, something like that. All the angles add up to 180. So we now know this is 26 and she can set that up. Okay. How would you solve those 2 equations? What method would you use for solving when you have a fraction equal to another fraction? Delaney, what do you think? Cross multiplied, I think, would be everybody's favorite. These are basically proportions. One ratio equal to another ratio. We describe that as a proportion. So we would cross multiply A times sine of 36 equals 14 times sine of 26. And then to solve for A, you're going to divide by the sine of 36. What should you do with your calculator before you start typing things in? Make sure it's in degree mode. Okay. So we're going to be, many times in chapter 6, we're going to be working in degree mode. So go ahead and make sure your calculator's in degree mode right now. Over here we could do the same thing, cross multiply. This time we get b times sine of 36 equals 14 times sine of 118. And we're still going to have to divide by the sine of 36. Does anybody have either one of those decimals? Lucy, what'd you get for what, those?
For A, I got 10.
10.44. Can anybody verify that? Okay, and then B? 20.03? 21.03. Okay, so that's a matter of typing that into your calculator and making sure that you're getting the correct answers. Okay? So that's basically set up for log signs. How many people have done this before in physics class? You've done it in Algebra 3? And possibly also Algebra 2. If you came from Algebra 3, this is probably the third time you've seen it. We didn't do it in Algebra 2 last year, so if you're coming from Algebra 2, you haven't seen it. It wasn't in the new book. Okay, so not that many. This is set up for log signs. Don't worry about all three ratios. You worry about 2 at a time. And always make sure you pick the one where you know both pieces. And go on side lengths. Are there any questions about what we did on the board that I can clarify for you? Okay, we have one other thing that we want to talk about real quick. It's another formula. It is the area of a triangle. And could you please tell me how to calculate the area of a triangle? 1/2 times base times height. Excellent. I'm going to write that right here. Area equals 1/2 times base times height. What do you suppose is one issue for us in this triangle? We do not know height, right? So I would guess the way I have my triangle drawn, most people would imagine the height right here. Okay, the height has to be perpendicular to one of the sides. And certainly could draw height at any side. So we know that we could call B as our base in this example, okay? But we don't know the height, okay? Use your right triangle trick, just like we did on the pink sheet. If you draw in that altitude, SOHCAHTOA is now acceptable because you've created a right triangle. So I've actually created 2 right triangles. If I focus on this triangle on the left, okay, I can write an equation that involves the height that says the sine of A is equal to H over C. And I think in the pink sheet you would have done K over C, right? Okay. Well, then I can solve for my height. The height is C times the sine of A. So if I call the height C times the sine of A, can I now calculate the area? Yeah, one formula for area of a triangle would be 1/2 times the base, which would be B right here. Okay, that's where my height is perpendicular. And then times C times sine of A. Okay, so that's one formula for area of a triangle. If I look at the height from a different angle, that will change things. Suppose I look at it from C. Then I would say the sine of C is equal to H over A. So H is equal to A times sine C. And I could use that as my height and B as my base, and I would have another formula that looks like area equals 1/2 times base times A times sine C. Now, I'm going to switch this guy around because most mathematicians like their letters to be in alphabetical order. So even though this is base times height, it's all commutative down there. I'm going to write A times B. That's me being picky. I want my things to be in alphabetical order. What do you notice about the 2 side lengths compared to the angle? that are used in each of those formulas. In the first one, side B and C and angle A. In the second one, side A and B and angle C. What do you notice? How do the sides compare to the angle letter? Marcus, what do you think?
Use like two of the sides and then the angle of the other one.
Yes. The two sides that are in the formula are not the same as the angle that comes in the sign. So, you have to be responsible for this area formula. I wouldn't memorize all three formulas because there's another one with sine B, right? Okay, what I would do is just know that I'm using the two sides, B and C, then I'm using the angle that's not for side B or side C. So I'd be using angle A. When you look at the picture, if you're doing sides B and C, then angle A is what in geometry you might have called the included angle. It's the angle in between or formed by the sides B and C. And if you're doing the second equation, when you look at sine of C, C is made up of A and B. So what would my other equation be? Area equals 1/2 times A times C times sine of B. And of course, we're mathematicians, so we would want to write it in that alphabetical order. Okay. You are responsible for the area formula. Okay. I would not memorize all three of them. I would sort of look for that pattern that Marcus pointed out for us. The two sides and the included angle. It's the angle that doesn't match up with the two sides. Okay, so one more example, and that's going to be finding the area of the triangle. So I'll give that to you here in just a moment so that everybody can get those formulas copied down. Find the area of the triangle if A is 65 degrees, B is 15, and C is 22. If you want to draw a picture, by all means you can. The picture is nice for some of us just to make sure, like, do we have the pieces that we need to find the area of this triangle? Yeah, we have two sides and their included angle. Okay, so think about, like, one way you would have called that in geometry, two sides and an included angle, you would have called it like side, angle, side. Remember those things? Those things are going to come back to us. Okay, so I'm ready to go. I would use the formula area equals 1/2 times B times C times the sine of A, right? I have two sides and the included angle. So 1/2 times 15 times 22 times sine of 65. I've got all the pieces I need. Now think about, like, if it didn't give me a piece I needed, I would do law of sines to find the thing I need. Stephen, did you get a decimal for that area?
Yep.
What'd you get?
149.5.
149.5. Can anybody verify that? And we're always going to do what to areas? Label them. Units squared. If it gave me units, I would use that unit term. So if it gave me inches or feet, I would use that. It does not, so just call it units squared. Make sure your calculator is in degree mode. Any questions with that? Okay, your homework assignment is on your gold sheet. This is not a long assignment, so I'd really appreciate